Hello, geometry students. Mr. Zacek back and better than ever. We're in our unit on transformations. And so far we have looked at translations and we looked at line reflections. And today we're going to look at rotations. And a rotation is a transformation that turns a figure around a point called the center of rotation. When I think about rotations, for some reason, I think about like water skiing. So if you're water skiing, I think there's two eyes in that, but I'm not sure. Kind of two eyes looks wrong. But if you're water skiing, you're behind the boat and you're attached to the boat at that point, wherever the rope is tied to. That's like your center of rotation. Now your distance away from that doesn't change as long as you're standing up, but it moves back and forth. So the number of degrees a figure rotates is considered the angle of rotation, and the counterclockwise direction is a positive angle of rotation. So whenever we have a positive angle of rotation, it's always going counterclockwise. So you'll notice here that you've got the center of rotation again, and every point is being rotated in that way. So couple things that we can observe about this is that the distance between the center of rotation and A is equal to the distance between the center of rotation and A prime. And that would also be true for like B and B prime. Those two distances would be the same. And it would also be true for C and C prime, that those distances would also be the same, because it doesn't get any further away from the center, it's just moving along in that. And so our notation here, you'll notice we're using capital R. With lowercase r we use for a line reflection, capital R. And so the point C that you see, and then the degree of rotation. So rotate P 90 degrees about center of rotation C. Okay, so you always have to have a center. So we need a point and a degree. So rotations preserve distance, rotations preserve angle measure, and therefore a rotation is a rigid motion. All right, so just as a reminder, so rigid motions, which ones do we have rigid motions? Number one, they preserve distance. Number two, they preserve angle measure. Preserve angle measure. So far in our unit on transformations, everything we've done so far has been a rigid motion. The translation, the reflection, the rotation are all of those are rigid motions. Okay, we're going to look at a rotation in the coordinate plane. All right, now very often, all right, so the most common rotation that we have are centered at the origin. And the origin is the point 0, 0. Okay, so when you see this letter O, what it's referring to is that it is centered at the origin. So what happens, and this gives us the rules of rotation that you have right here. The first one is centered at the origin, and it's 90 degrees, and it takes this point xy and it makes it negative yx. So this is our xy, this is our negative yx. Well, you'll notice here a couple things. Number one is this is a right angle, and then those distances are the same. A rotation of 180 degrees, you see it here. Okay, this is our xy, and this becomes negative x, negative y. A rotation of 180 is the same as a reflection through the origin. So if you ever have to do a reflection, it's the same as a rotation of 180 degrees. And then the last one is 270, and so you see that this angle here, again, it's counterclockwise, is 270, and it takes this point xy and makes it y negative x. Now when you see that negative x, what that just means is the value changes. So if it's positive, it becomes negative. If it's negative, it becomes positive. All right. So, and then what we said here, I just wrote there, a rotation about the origin is equivalent to a reflection through the origin. All right, so the best way to do this is a little hard to illustrate as I'm talking to you. It's something that I'll show you in class, but instead of remembering these rules, the easiest way to do this is to plot the pre-image, and then depending on the what you have, you just turn the paper left once if it's a 90-degree angle, twice if it's 180, 3 times if it's 270, and you find the coordinates of the point now. These are the prime points, and so then you turn the paper back to the original position and plot the new points. Again, a little hard for me to illustrate that because I can't like pick this and move it, but what I'll do is maybe I'll try to make another video where I show just turning the paper, and you can have that. So, but this is a really simple way, instead of remembering all those rules that you have up here, just turn the paper, make sure that we turn it left. Okay, so kind of going along here with our vocabulary, a rotation turns a pre-image a given number of degrees with respect to a center of rotation. So a rotation of positive degree measure turns a figure counterclockwise. You might think of that as to the left. The distance between a point on the pre-image and the center of rotation is equal to the distance between the corresponding point on the image and the center of rotation. So that's we're riding on our, we're skiing behind a boat and we turn to the other side. We're still the same distance away from the boat. Under a rotation, the angle formed by a point, the center of rotation, and the corresponding image of the point is equal to the degree of rotation. So how we turn it, you know, it creates an angle. A rotation of 180 degrees is equivalent to a point reflection. I don't like how this is worded, through the origin. Just add this on the end of it. Okay. All right, so which of the following are invariant? Again, invariant means doesn't change. Distance, yes. It's a rigid motion. Angle measure, yes. Orientation, yes. That's a tricky one. People forget that. But the order of the letters is still the same, even though it kind of gets turned. Perimeter is yes. Area is yes. Collinearity, yes. Parallelism, yes. Perpendicularity, yes. Okay, so this is a direct isometry. Okay, so again, the orientation does not get reversed, does not change like it did in a line reflection, meaning the order of the letters. All right, so let's go ahead and do a few of these, show you how I like to write it out and how I would encourage you to do that. So we're going to start with the points. I like to write them out like this, again, in the vertical lineup. Okay, 3, 3, R is 4, 1, and S is 3, 0. I'm going to plot these over here. So P is 1, 1. Okay, Q is 3, 1, 2, 3. R is 4, 1, 2, 3, 4, 1. and S is 3, 0. All right, so might connect these. Now, what it wants us to do is graph a 90-degree rotation. So what I'd like you to do is to take your paper, and what I want you to do is turn it once to the left. So just pick one of those points and turn it to the left. We'll just do them one at a time. So we'll do P first. We want to get P prime. We want to get Q prime. We want to get R prime. And we got to get S prime. Okay, so give me a minute. Take P, turn it once to the left, and what do you notice? Well, that's now negative 1, 1. And then turn it back and write it down. Okay. Now, one of the ways you can check that is when you do that, does it create a 90-degree angle? So if you drew a line from here to here, does that create a 90-degree angle? And it does. All right, so what about Q? Well, okay, turn it once to the left again. Q is negative 3, 3. About R? Negative 1, 1, 2, 3, 4. And then S prime would be 0, 3. So I like to write them all out before I actually go and graph them, just figure it out. So then Q is negative 3, 3. This is Q prime. R prime is 1, 1, 2, 3, 4. R prime. And then S prime is 0, 1, 2, 3. So S prime is here. Take my straight edge, connect these. Okay. So it's got some questions just to think about and to help you kind of solidify some of these ideas. So connect P to the origin and P prime. So I did that before. What is the measure of that angle PO P prime? It's this angle right here. Well, that's the angle of rotation. So that's a 90-degree angle. Find the measure of, and then it wants us to do all of these. It's the pre-image. Okay, so this first one is the pre, the center, and the image. Well, what are all of those going to be? Since we did a 90-degree rotation, all of those are going to be 90-degree angles. With a 90-degree angle, sometimes what I'll do is I'll just put a piece of paper in there, because the paper, if you've got a factory produced paper, the edge should generally is a 90-degree angle. All right, now what do we notice about PO and OP prime? Well, that's this distance. This is our ski line. Those are equal to each other. So QO, from Q to the center, and so this again is, here's your pre-image, point Q, center, and then center to the image. Yeah, that doesn't change. They're still the same distance apart. So all of those are equidistant from the center of rotation. All right, so let's go ahead now and let's do another one. This one is going to be same starting points. So R is 4, 1 and S is 3, 0. Except for this time we're going to do a rotation of 180 degrees. So whoops, P prime, Q prime, R prime, S prime. So again, I'm going to go ahead and I'm going to plot these points. P. And if you want to do it one at a time, you could just stop here and now turn it twice. And when you turn it twice, what you're going to find is that P prime is negative 1, negative 1. Okay, that's going to be point P prime. So Q, which is 1, 2, 3, 1, 2, 3, Q prime, let's turn the paper 2 times to the left, and you're going to get -3, -3, which would be down here. Look at that. That's actually a 180-degree angle. There's a straight line through the origin that connects those points. How about 4, 1? Well, that's going to be -4, -1. Whoops, I forgot to plot it. 1, 2, 3, 4. Okay, again, turn the paper twice, and it's going to come out to be here, R prime. And S, 3, 0, turn it twice, -3, 0. 1, 2. Okay, so S prime. Let me connect those. Did I plot one of those wrong in the other one? I feel like I plotted the, I did the, no, okay, I did that right. Yeah, so there we go. That's how you do it. Now, you might notice some of you kind of pick up on, you'll identify the rule. So sometimes as you're doing it, you find the rule. And the rule is, in this case, xy becomes -x, -y. So sometimes one way to do it is you could just plot one point and figure out the rule and then apply the rule. All right, so what is the measure of PO, P prime? Well, that's our rotation, 180 degrees. They're both going to be equidistant from the center, the pre-image and the image. And a rotation of 180 degrees is equivalent to a point reflection through which point? Well, through the origin, or the point 0, 0. So you'll notice that they're equidistant from the origin, those ones there. Okay, we got a couple more here. We got a 270, and then the constructions are a different lesson here. So, all right, so all we're going to do here again, 1, 1, 3, 3. We're using the same points because I just want to show you the difference between these ones. S is 3, 0. So again, I like to write them out all vertically, and then P prime, Q prime, R prime, S prime. And so if you want to do it one at a time, this time what we're going to do is we're going to turn the paper 3 times to the left. So pick your paper, turn it left once, turn it left twice, turn it left again, and you come out with that one being at the point of 1, -1. So here's our P prime. Okay, Q, which is 3, 3, goes down to turn it once, turn it twice, turn it 3 times, and it's going to be 3, -3. Whoops, 3, -3. Q prime. And then R, which is 1, 2, 3, 4, 1. Okay. So we turn that, and I have to, hang on, give me a sec here. I'm going to draw it out on my own piece of paper because I'm having a hard time. 1, 2, 3, 4, 1. Okay. Turn it once, turn it twice, turn it 3 times. That becomes 1, -4. And then S prime, so let's plot that. So this is R, and then 1, hang on, 1, -4. That would be R prime. Did I get Q right? Let me try Q. 3, 1, 2, 3. 1, 2, 3. I did get Q right. Okay, and then S, which is 3, 0. Turn the paper left once, twice, 3 times. That's 0, -3. So 0, -3. There's our S prime. So S. Okay, so P, whoops. Get our line here. Q, R, S. Okay. One of the things I want to point out in terms of like your orientation in how is it that it doesn't reverse? Well, if you start with P here, just use a little highlighter to show it to you. If we go P, Q, R, S, if we start here, we go P, Q, R, S. That's what it means about the orientation not changing. It's the order is the same. Okay. All right, last one. WKYZ is a parallelogram and T is the midpoint of the diagonals. How can you use the properties of rotation to show that the lengths of opposite sides of a parallelogram are equal? Okay, so I'm going to highlight here. And then we've got the sides. Well, what would happen here if we rotate it? If you just picked this up and you turned it upside down, which would be a rotation of 180 degrees. So here's what we're saying is that if we rotated about point T 180 degrees, point WZ, what would that land on? Well, WZ would end up becoming YX. And then if we rotated about point T, a rotation of 180 degrees, and we did point WX, the green ones, what would the image of that be? Well, WX would go around and it would become YZ. So what we've shown is that therefore, since a rotation is a rigid motion, that preserves distance, we could say that WZ would be congruent to YX, and we could say that WX would be congruent to YZ. Okay, so we have those there. Alrighty, so got the stuff. There are a couple other things on the assignment that are a little bit different than in the notes in terms of they're not all coordinate ones. There's some other ones that we have to use kind of these concepts of rotation. So if you're having a little challenge with that, please ask a question. But just a heads up, there is a little bit of difference as you're doing some of those questions. The majority of it is the coordinate plane stuff. All right, I will see you back here soon.